Welcome to you all. This is Martin Kagan. I'm doing a review and a recap of a presentation based on hierarchical, statistical, and to a degree unstructured data. We're going to be looking at a number of spatial data schemas based off the license patterns of before your eyes. Implicit in them is this singular diagram over here, which is the hex Cartesian plane portrayed three-dimensionally. As you can see, we have a center point 0, 0, 0, and we have parents 1 through 6, main parents with subparent being 1.1 through 1.6 in their relative numbers throughout each. And out on the outlier of that, in the third element of the dimension, is the node or the child itself. And we take this and we represent that three-dimensionally through an Excel grid format, and we'll look at that in a moment. Here we have the actual input sheet with a date line, with an index which is numerically structured, and as you can see, the data sheet is fairly large, and the numbers are difficult to obviously comprehend and read, but when we see what we can produce out of this, it's another thing entirely. So what we're looking at is some of the traditional two-dimensional graphs seen three-dimensionally. Specifically, we're going to be looking at the sunburst and the spider graph in 3 dimensions. Some of them look like what you're going to be seeing in a moment. This is just a catalog of some of the previous visualizations that we've done to give you an inkling of the complexity and the beauty and granularity, for that matter, of the data itself. As you can see, it's a wide variety of options that it produces, but essentially they are variations of the sunburst in the actual pattern itself. And we're going to dive straight into one of the examples, which is the house price index of the USA. What we have here is time on the upper right-hand corner, a period of several decades. And then we have on the inner dimension the regions of the USA, and each region has a number of states, and we immediately are trying to find meaning to the data. So we'll go right to the nth data as we have it over there, and we're going to look and observe, and from observation we can pick out sections that are highest generating. Here's New England, for instance, Massachusetts as the center core, and we can compare that to the District of Columbia, which is the highest area, and here we have a singular view of what that represents in terms of percentage increase of the node and its value, and we can drill back downwards to see its regional representation and comparison at the regional level. And once again, we can look at it in its entirety from that point of view. So what we have here is several windows all interacting in time and giving it immense clarification. We can pick up, or if we wanted to go for the number itself, we can actually just generate from the number and get a holistic. But as you can see, the descriptor has got the price index model and the details relative to that. From that, we will move on. And we're looking now at the rose model relative to that. Before, it wasn't a perfect rose, it was 9 sectors. This is the 6-sector element, and you can see it in interplay here with its data dimensionality. We switch from that and we quickly change the dimensions to 3. And on the 3, we can only see the inner parent layout, and that already accumulates a lot of information. That is essentially at the regional state level. So the center is the region, each of these are the states, and we're able to get clarification from that point of view. There's changing that back so we can always go back to it. We said that there were 10 dimensions or dimensional aspects that we're able to relate to in depth of these clusters over here. This is only 4. We could take it all the way if we so desired. With that said, we once again move along, and we now are looking at, instead of time, we're looking at incidents or itemized elements to the graph. And here we are looking at 100 odd students, and their scores could be college students or school students. And as you can see at the bottom here in the data column, a spread of student scores. It would be nice to be able to see that and how that pertains to the class or to the year, or for that matter, to the course itself.